Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let's start our class today by reciting prayers and blessing upon Nabi Muhammad sallallahu alaihi wasallam. Bismillahirrahmanirrahim. Rabbi zidni ilman warzuqni fahman. Allahumma salli ala sayyidina Muhammad salatan taj'aluna biha min ahli ilmi zahiran wa batinan wa tahsyuruna bi'ibadika salihin fi dunyana wa akhrana. Today, we will start our discussion on Chapter 1, Distribution Systems and Tariff. So, as you can see, there are 7 subtopics in this chapter. Begins with the introduction in the subtopic 1.1, followed by electricity generation scenario in Malaysia, and then electric supply system, followed by high voltage distribution networks, low voltage distribution networks, and then hardware for distribution system, and finally load characteristic and tariff rate. So now we will start with the introduction part. Okay, as for introduction, energy is needed in many areas of human endeavor, such as transportation, agriculture, industry, commerce, and also household. So, in transportation, the energy is needed for moving people and goods around. Meanwhile, in agriculture, the energy is needed to produce and process the foods. And then, in the industry, the energy is needed for manufacturing of useful materials and artifacts. And then, in the commerce, the energy is needed to powering communication, gadget, equipment, and going about other commercial activities. And finally, in the household, the energy is needed to maintain the physical comfort and convenience in our homes. Okay, so here are some explanation on aforementioned 5 areas. So we start with the transportation. So in the transportation, the movement of peoples and goods from one place to another. So transportation depends on the continuous supply of energy. So transportation, as we know, such as automobiles are powered by gasoline, and then transportation like aeroplanes by jet fuel, and transportation like trains and ships by diesel oil. So all this transportation use conveyors, cranes, robots, and pipelines that use motor and pumps which are powered by electricity. And then in the agriculture, we know that agro-industry and processing of agriculture products require energy. Mechanical implements powered by fuel or electricity are immensely more efficient and productive than human and animals. So, in the developed countries, a major portion of electricity used in agriculture powers by irrigation pumps. Then, the energy requirement in agriculture are mainly met using solar energy, fossil fuel, fuel woods, and also electricity. So, in the industry area, energy is mostly needed by the machine and process which make the products of the industry. Energy also used to heat or cool the building and provide hot water and other facilities for workers. Industrial energy consuming systems include boiler and other fired systems, compressed air system, electric motors, and also lighting systems. Meanwhile, in the commerce area, suitable energy is needed to have highly sophisticated communication systems for both supplies and service. And then energy in commerce is basically used for information processing, SCMV, and lighting. Electrical energy is the most common form of energy used and supplemented by chemical energy from batteries. In the household areas, energy is required in the household for space heating or cooling, water heating, cooking, lighting, ironing, and etc. So, energy may come from direct heating from the sun, electricity, burning of fossil fuel or foil wood. Okay, now we will move to the second subtopic, electricity generation scenario in Malaysia. Okay, so this is the generation mix profile in Malaysia for installed capacity by fuel type in the year 2012. So from the figure, we can see that more than 50% installed capacity is given by the natural gas compared to. Meanwhile, for installed capacity by power producer in the year 2010 is given by the pie chart. So, we can conclude from the pie chart that more than 50% power producer is given by IPP. So, IPP is independent power producer. And then 25% is given by TNB. And finally, other power producer with the small percentage. Number of consumers by sector in Malaysia in the year 2012 is shown in the pie chart. From the pie chart, we can see that most energy consumption is given by transport sector and then followed by the industry sector. Only 2% from the agriculture sector, while the residential and commercial and non-energy use give similar percentage, which is 15 and 16. Okay, this is the sales of electricity in Peninsula. We can see that higher sale of electricity is given by the industry sector and then followed by the commercial sector. And then the third sales of electricity is given by the domestic sector, and other sectors such as export, public lighting, mining, and others give only below than gigawatt per hour. Okay, this is the major power station in the Peninsula Malaysia in the 2010. So we can see that there are two types of power station. The red triangle is hydropower station, and the blue is the thermal power stations. So we can see that the thermal power station is more than the hydro power station. Then this is some of thermal power plants in the Peninsula Malaysia. Teluk Ewa, and then at the Pride, at the Gelugu, we have also at the Manjung, and then KV, and then Serdang, Connaught Bridge, Port Dickson, Tanjung Bin, Pasir Gudang, and Pakar. And then some hydropower plants in the Peninsula Malaysia, we have Tenggur, Bersia, Kenering, Cenderoh, Pergau, Sungai Piah, Cameron Highland, and finally Kenyir. So this is the maximum demand and installed generation capacity in the Peninsula Malaysia in the year 2010. So we can see that the maximum demand is increased year by year from 2006 until 2010, and then the installed capacity from the IPP and also TNB also increased. Then, maximum demand and installed generation capacity for Sabah in the year 2010 also give the same trend, which is increase from the year 2006 until 2010. So, how about Sarawak? We can see that similar trend also found in Sarawak in maximum demand and installed generation capacity, which is increased year by year. Okay, this is the TNB grid system in the year 2010. Okay, this is TNB grid system in the year 2006. For your information, the TNB grid system is controlled by SCADA system. This SCADA system is located in TNB Bangi. Okay, the major power station and grid system in Sarawak is shown in this figure. So we can see that the major power station is connected between the 275 kilovolt transmission grid system and also 132 transmission grid system. So here is 132, and the black one is 275 transmission grid system. And then major power station and grid system in Sabah in the year 2010 is given in this figure. So we can see that there are three types of power station in Sabah, which is SESB power station, and then IPP power station, and then hydro power station. This is perspective Asian power grid. So you can see this power grid by yourself. So now we go to the third subtopic, which is electric supply system. Electrical supply system can be divided into two: medium or high voltage, in short HV, and low voltage, in short LV. So, medium or high voltage is used for overhead transmission line such as 500 kV and 275 kV. And then for underground cables, the voltage rating is 132 kV, 66, 33, 22, 11, and also 6.6 kV. High voltage also used for large scale industry customers. And then for low voltage, it is used for voltage level below than 1 kilovolt, such as 230 volt and 400 volt. Low voltage also used for residential, commercial, and small industry applications. So, the definition of voltage level can be divided into low voltage, medium voltage, and also high voltage. From this figure, we can say that low voltage is defined by the voltage below than 1 kilovolt. And then for medium voltage, we can define that the voltage between 1 kilovolt and also 550 kilovolts. So for high voltage is the voltage more than 50 kilovolts. Okay, for low voltage system, it can be single phase, 2-wire, 240 volt up to 12 kVA maximum demand, or it can be 3-phase, 4-wire, 415 volt up to 45 kVA maximum demand, or it can be 3-phase, 4-wire, city metered, 415 volt up to 1000 kVA maximum demand. Meanwhile, for medium and high voltage, it can be 3-phase, 3-wire, 11 kV for load of 1000 kVA maximum demand and above, or it can be 3-phase, 3-wire, 22 or 33 for load of 5000 kVA maximum demand and above, or it can be 3-phase, 3-wire, 66 kV, 132 kV and 275 kV for exceptional large load of above 25 MVA maximum demand. Okay, now we move to the steady state supply voltage performance. So under normal conditions, the voltage will be varied by this percentage. Meanwhile, under contingency condition, the voltage will vary more than the under normal conditions. So we can see that the variation under normal and contingency is different. So the variation is more under contingency conditions. So you may ask me, what is the meaning of variation? So the variation can be said as the voltage drop. Okay, for security level for distribution system, we can say that for voltage level of 6.6 kV, 11 kV, 22 kV and 33 kV, the average supply restorations is less than 4 hours. How about the voltage below than 1 kV? And then for that, for supplies at 230 volt and 400 volt, so the restoration period may vary beyond 4 hours depending on the type of network fault. So this is the overview of electricity supply system. We can say that this is the transmission part, and then this is the distribution part. So this part, the transmission part, you have learned it in the subject power generation. Meanwhile, for utilization of electrical energy, we will focus at the distribution part. So we will see you again in the part 2. Thank you so much for listening and focusing.